Welcome to Sotantra education. In the previous lecture, we have discussed how to handle the exceptions using the try and catch block. Now consider a simple program. So like this. So we are writing a class and assume the name of the class is test, and in the class test we are writing public static void main, then string array args. Now suppose I am writing a simple statement here, system dot out dot println. Suppose I am writing 5. Okay, let us remove this one. Okay, so 5 division 0. Now end of main method, end of class test. So here this statement, so for this statement print 5 by 0, the exception occurs for the execution of this statement, and when the exception occurs, actually an exception object is thrown, and we need to manage that exception or we need to handle that exception using the try catch block, otherwise the program is going to terminate abnormally. So here you can observe, when the exception is thrown or when one exception object is thrown for this statement, who is actually throwing that exception? Now Java runtime system is going to throw that exception automatically. So who is throwing? Java runtime system. Now as a programmer, if we want, we can also throw a exception as per our requirement. Suppose I can write or I can update this program here like this. So here I can write class test, then public static void main, string args, then you can write suppose scanner IP equal to new scanner system.in. Now suppose store that value in an integer, suppose int n equal to ip dot next int. Okay, so here you can write import java dot util dot scanner. Now here I want to throw an exception when the value of n is less than 0, or we can say for negative numbers or for negative values n. As a programmer, I want to throw an exception or in particular arithmetic exception manually. Now in that case I can write if n less than 0, then throw. So here I can write, so throwable instance, so it is not actually, so let me write here. So we can throw a throwable instance, or we can write a throwable object, because actually an object of throwable class or any of its subclass is thrown. So we can write throwable instance, or that is same as a throwable object. So how to create one instance of class throwable or one instance of any of the subclasses of the throwable class. So generally we throw the instance of the exception class or any of its subclass, because error also comes under this throwable class. That's why in generally we throw one instance of the exception class or any of its subclass. So how to create one instance or one object of the exception class, or in particular consider arithmetic exception class. So we are not going with exception class now. Now we are going to discuss about the arithmetic exception particularly. So for n less than 0, we want to throw an arithmetic exception object. So how to create one object of arithmetic exception? We know that to create one object of a class, we can use the new operator, or we can use the keyword new. So if we want to create one object of the arithmetic exception class, so we can write new arithmetic exception. So this statement creates one object of this arithmetic exception class. Now we want to throw this arithmetic exception object. So for that we can write throw then new arithmetic exception. So just remove this part and simply write throw new arithmetic exception. Arithmetic exception, after that this one is parenthesis, empty parenthesis. Or if we want to pass a string value for the error message, we can pass inside this parenthesis. So for that we can write here like this. Suppose I am writing here throw new arithmetic, it is a single word, exception, and pass the message, suppose negative numbers not allowed. Like this we can pass the empty string, or you can make the parenthesis empty, or you can pass one string message inside this parenthesis. So in this way we can use, or we can manually throw an exception using the throw keyword. So now let us check how it works. So now let us write a simple program that is going to show the details of throw keyword. That means how we can manually throw an exception using the keyword throw. So for that let us write a simple program like class test, then we can write public static void main. So we can write string array args, then we can create one object object of scanner class like scanner IP equal to new scanner system.in. Now here we can write int n equal to ip dot next int. Now we can write if, suppose previously, or let us print that value, we are entering system dot out dot println you have entered, and suppose the value we want to print. Okay, now here we can import the scanner class. Import java dot util dot scanner. Okay, let us check this program. Here we can write another println statement, that is enter a number. We can write enter a number. Okay, now let us compile this one again. Okay, successfully compiled. Then run this one, java test. So enter a number, suppose you are giving 6, so you have entered 6. Suppose another number 10, you have entered 10. Suppose another number -5, so it is saying you have entered -5. Okay, now suppose we want to throw the exception if the value of n, so for simplicity write greater than 10, or you can take for negative numbers, no issues. So if n is greater than 10, throw new arithmetic exception. Okay, so we are writing with empty parenthesis. So now let us check, if n greater than 0, it is going to throw the exception. So let us compile this one. Okay, so successfully compiled. Then java test, suppose you entered 5, so it is saying you have entered 5. Now suppose you have entered 9, so it is saying you have entered 9. Now suppose we are entering another number 50, so it is saying exception in thread main java.lang.arithmetic exception at test.main test.java8. Similarly, if you enter 11, it is throwing the exception, because here we are writing that if n greater than 10, throw new arithmetic exception. So here manually the exception is thrown using the keyword throw for the value of n greater than 10. Similarly, whenever there is a requirement, you can manually throw the exception using the throw keyword. Now here if we want to pass some message, here also we can pass some message like the maximum value should be 10. Now let us check. Successfully compiled. Enter a number, suppose 6, so it is saying you have entered 6. Now entered another number, suppose I am writing 47, So it is showing exception in thread main, this java.lang.arithmetic exception, and it is showing the message the maximum value should be 10. So here you can observe the maximum value should be 10. So this message gets printed on the screen. So I hope this is clear to everyone. So we have discussed that when an exception occurs, actually an object is thrown. Now the object contains some information, and by default that is printed on the screen when the exception is thrown. Now when we use try and catch block, that information never gets printed. Now if we want to print that except the details in the detail information about the object, then we can use the predefined instance methods that are defined in the throwable class. So what are these methods? So these methods are like get message, so this method returns a string and it displays the message of the exception. Similarly, we have another method, that is toString method. So this method returns the full name of the class, full name of the exception class, then column, then the message of the exception. Then we have another method, print stack trace, print stack trace. So it actually prints the stack trace or call stack where the method actually occurred. So it returns the stack trace or call stack method. Or we can say it is call stack information. So what is call stack? We will discuss later. So in addition to these three methods, some other methods like get stack trace method are also there, but basically or generally these three methods are used to get the information about the object, or we can say to get the information about the exception object. So now we will modify this program and see how we can use get message method, toString method and print stack trace method to get the information about the exception object. So let us, this one we can use a catch block here, catch, suppose arithmetic. So this one is arithmetic exception, suppose E. Then we can write here system dot out dot println the message is the, okay, simple,
the message is, we can write e dot get message. Okay, so here just write plus. Now we can write this one to string, the to string method. Suppose we can write the to string. Okay, so let it be message. The true string message is e dot to string. Okay, so now write this inside a try block, try, then this one. Okay, so let us check how this program works. To string. Okay, it is capital S. So it is capital S. Okay, successfully compiled. Enter a number. Suppose you are entering 5, no exception generated. Then enter a number. Suppose write 87. So here you can observe the message is, the maximum value should be 10. So we are writing this message, the maximum value should be 10. So that's why it is showing. So it is showing for the get message method. Now another one, the toString message is, so it is showing the full name of the class, that is java.lang.arithmeticexception, then column, then the message. Now suppose I want to update this one, so let us comment these two statements and just see how the print stack trace method works. So we can write e dot print stack trace. Okay, so let us check what will be the output. Okay, successfully compiled. Java test, suppose enter number 5, so no exception occurs. Again run, suppose 45. So here you can see java.lang.arithmeticexception, the maximum value should be 10 at test main test.java 9. So that means in line number 9 of test.java file and at main method in the test.java file, and it is showing the full name of the class and also the message. So print stack trace prints the full name of the class, the message and the stack trace information or call stack information where the exception actually occurred. So I hope the use of these three methods are clear to get the information about the exception object. Now consider this figure. Suppose we have statement 1, statement 2, 3, 4 like up to statement n in the try block, and similarly catch block 1, catch block 2, catch block 3, catch block 4 up to catch block n are there. Then the next statement is there. Now in the left part of this figure, that means this one, consider assume T statement 3 throws an exception and catch block 3 is the matching catch block.
So in the try block, statement 1 gets executed, this 2 gets executed, and the statement 3 throws an exception. So when the exception occurs here, then the rest of the statements in the try block are going to be skipped. We have discussed this in the previous lecture. So that's why you can observe this yellow section represents the skipped portion. So when statement 3 throws an exception, or you can say when exception occurs at statement 3, the rest of the statements in the try block are not going to be executed, and the control comes to the catch block. So here you can observe, so JVM try to match whether the thrown object at statement 3 is an instance of the catch block 1, or we can say is catch block 1 can handle the exception that is thrown at statement 3? No. So is catch block 2 is a matching catch block? No. Then catch block 3 is the matching catch block, because here it is written that catch block 3 is the matching catch block. So as catch block 3 is the matching catch block, or we can say catch block 3 is going to handle the generated exception object that is thrown at statement 3. Now this catch block 3 is going to be executed, or the statements that are written in the catch block 3 are going to be executed. Now once this catch block executed, the rest of the catch blocks are skipped, or we can say are never executed. So here catch block 1, catch block 2 are also not executed, but the catch block 1 and catch block 2 are checked that whether this catch block 1, catch block 2 is going to manage or going to handle the generated exception. So once a matching catch block is found, then the statements in that catch block are going to be executed. So here catch block 1 and catch block 2 are tested, not executed. So the JVM is going to test whether catch, or going to verify whether catch block 1 can handle the exception or catch block 2 can handle the exception, but actually the statements written in catch block 1 and catch block 2 are never going to be executed. Then after executing these statements or the catch block 3, the control comes to the next statement that is written after the catch block n. Now consider this one, this figure. So when no exception occurs, so in the try block no exception occurs, then the catch block part is going to or not going to be executed. So when no exception occurs, the catch block is skipped. So for the exception, when the exception occurs, the corresponding matching catch block is going to be executed. So if no exception occurs, the control directly comes to the next statement that is written after the catch block. Now consider another figure. So here we have method A, and in the method A we have one try block, and in the try block we are calling method B. So we are writing this B, that means we are calling method B, or we are invoking method B. So when this statement gets executed, the control comes here, that means method B going to be executed. So inside method B we have, or we are calling method C. Now the control comes to the method C. Now in the definition of method C, or inside method C, we are calling method D here. So the control comes to the method D. Now method D throws an exception. So here you can observe, so we have one call stack to represent the method calls. So assume this is the call stack. So initially we have method A according to the figure. So A is inserted in the call stack. Now the method A calls method B. So here you can observe we are calling method B in A. So method B is written here or inserted in the call stack. Now in method B, here you can observe we are calling method C. So method C is inserted in the call stack. Okay. Now here you can observe in method C we are calling D. So D is inserted in the call stack. So when the exception occurs at method D, the JVM is going to check whether the method D is going to handle the generated exception. So here you can observe no catch block is there or no exception handling code is there in the method D. That's why the method D cannot handle the exception generated or exception thrown here. So when the JVM is going to ask that method D, you are generating one exception, can you handle that? So method D simply denies, no, I can't handle that exception. So in that scenario, what is going to happen? So in this scenario, the JVM is going to terminate method D abnormally and removes that from the call stack. Now it comes to the caller of the method D. So who is calling method D? Method C, or you can observe here the method that is below method D, that is the caller of method D. So here in this example here you can observe method C is calling method D. That's why method D is above the method C here. So when the JVM terminates method D abnormally and comes to method C, then ask method C that you have called method D and method D is generating one exception and method D is not able to handle that exception. As a caller, can you handle that exception? So method C also do not have any exception handling code. So that's why method C also tells that no, I can't handle. So here you can observe. So the JVM just terminate the method C abnormally or stops method C and ask its caller to handle that exception. So here you can observe who is the caller of method C. So method B is the caller of method C. That's why you can in the call stack also you can see method B is just below method C. So the control comes here or the JVM is going to ask method B that method B, can you handle the generated exception at method D, or you can say it is going to ask that method B, you are calling method C and method C is calling method D and method D throws an exception which is not handled by method D and method C also is not able to handle that exception. Can you handle that exception? And you can observe here in the method B there is a catch block to handle the exception E. So to handle the exception and E is a reference variable. So B is going to tell yes boss, I can handle. So now B is going to handle the generated exception and the JVM is not come to A because here the same exception is handled at method B. So if there are some statements here after the catch block, then they are going to be executed. So I hope this figure is clear to everyone and the concept of call stack is also clear. So call stack just stores the order of calling of the method or the order of call of the method. So similar to this, let us consider another one here, another figure. So here we have main method, then in the try block we are writing invoke method 1, then some statement 1, then in the catch block, so the catch block is going to handle exception 1, and we are writing process ex1, so ex1 is of type exception 1, then statement 2, then method 1, so method 1 also some try catch block, similarly method 2 also some try catch block, like this. So now here you can observe, so we have the call stack like this. So assume this is our call stack. So the first method is the main method here we are writing. So in the call stack the main method is inserted, assume. Now in the main method we are invoking method 1, so in the call stack method 1 is going to be inserted. Now when we invoke method 1 here, the control comes to the method 1. So in the method 1 we are invoking method 2 here, some statements are there, some statements are there, then we are invoking method 2. So when method 2 gets invoked in the call stack, we can insert here method 2. So now you can observe when we call method 2, so the control comes here to the method 2. Then in the method 2 we are calling method 3, or we are invoking method 3. So just write here method 3 in the call stack. So in the call stack it just stores the order of the invocation of the method. So like main method, then it is calling method 1, then method 1 is calling method 2, method 2 is calling method 3, like this. So here you can observe the method 3 is throwing one exception, and assume the exception is of type exception 3. So here an exception is thrown at in method 3, and assume that is of exception 3. The generated exception or the exception occurs that is of type exception 3 here. Now the JVM is going to ask that method 3 you are generating or you are throwing exception 3, can you handle that? Now method 3 replies, no, I can't handle. So the JVM is going to remove the method 3 from the call stack. Then it asks its caller, method 2 you are the caller of method 3, can you handle that exception 3? Then method 2 is going to tell, yes, I can handle the generated exception because I have the catch block that is going to handle the exception 3. So here in this scenario, statement 6 is not going to be executed because, sorry, statement 5 is not going to be executed because when we invoke method 3 and method 3 throws an exception, that means when in the try block this statement throws an exception, the rest of the statements are not going to be executed. We have just discussed. So statement 5 in this scenario is not going to be executed. Now the control comes to the catch block, and catch block is going to handle the exception 3, or we can say catch block is going to handle the exception that is of type exception 3. then statement 6 is going to be executed because the generated exception is handled in the catch block. So that's why the statements that are written after the catch block is going to be executed. So I hope this one is clear to everyone. Now let us consider, so here it is method 3, so here it is method 3, okay, method 3. Now assume the method 3 generates or throws one exception object that is of type exception 2. So here instead of exception 3, so it is of type exception 2. So method 3 throws an object that is of type exception 2. So here the JVM is going to ask first to method 3, that method 3 you are generating one exception of type exception 2, can you handle that? Then method 3 simply tells no, I can't handle. So this method 3 is removed from the call stack. Then the JVM is going to ask the caller of method 3, that means method 2. Then method 2 you are calling method 3 and method 3 is generating one exception or throwing one exception of type exception 2, can you handle that? Then method 2 replies no, I can't handle, I can handle only exceptions of type exception 3, I can't handle exception 2 exceptions. So the JVM is going to remove method 2 from this also, from the call stack. Then it asks the caller of method 2. So who is calling? Method 1. So it asks that method 1 you are calling method 2 and method 2 is calling method 3 and method 3 is throwing one exception of type exception 2, but they are not able to handle, can you handle that? Then method 1 is going to tell yes, I can handle because I have the catch block that is going to handle the exceptions of type exception 2. So here you can observe in this situation statement 4 is going to execute, yes or no? Yes, because statement 4 is after the catch block that handles the generated exception. So statement 4 is going to execute. Now statement 3 executes or not, because the exception occurs here. So in the try block, once the exception occurs, the control comes to the catch block, or we can say the matching catch block. So here this catch block is the matching catch block, so this statement is not going to be executed. So statement 3 is not going to be executed. Similarly, come to this here. So method 3 generates exception object of type exception 2. So like we have previously discussed, this statement 5 is never going to be executed, because once the exception is thrown here, the control comes to the catch block, matching catch block. So here we can say this catch block is not a matching catch block, so this process ex3 also not going to be executed. And as this catch block is not going to handle that the generated exception, the statement 6 also not going to be executed, because the generated exception is not resolved yet. So this process ex3 also not executed, statement 6 also not executed, only statement 4 is going to be executed in this scenario, and the call stack is like this. So in a similar fashion, when, so consider this is
method 2 and assume it is method 3, okay, in the call stack. So in a similar fashion, when this, so let us remove this part also. So when method 3 generates one exception of type exception 1, then what is going to happen? So just remove this 2 and it is of type exception 1. So it first, the JVM first asks method 3, can you handle? So method 3 replies, no, I can't handle. So it just removes this from the call stack. Then ask its caller, then method 2, can you handle exception 1? No, method 2 also replies. Then method 1, can you handle exception 1? Then method 1 also replies, no, I can't handle. Then it asks the main method. So main method, can you handle? Then main method is going to tell, yes, I can handle, because I have the catch block that is going to handle the exception of type exception 1. So here you can observe in this scenario, the statement 2 is going to be executed and statement 1 is not going to be executed. Similarly, statement 4 is not going to be executed, statement 3 is not going to be executed, statement 6 is not going to be executed, statement 5 is not going to be executed, and this process ex3 also not going to be executed, because exception 3, this one is not matching with exception 1. Similarly, this one is also not matching with exception 1, so this one is also not going to be executed, but this process ex1 is going to be executed. So I hope this one is clear to everyone. Now assume, so another type of exception, that is exception 0. Suppose the method 3 generates one exception of type exception 0. So now in this scenario, what is going to happen? So in this scenario, you can observe. So let us complete the call stack once again. So method 1, this is method 2, this is method 3. Okay. So now when the method 3 generates one exception of type exception 0, so at that time the JVM is going to ask first that method 3, can you handle the exception 0? You are generating one, or you are throwing one exception of type exception 0, can you handle that? Then method 3 simply replied, no, I can't handle. Then it asks its caller, with the caller of method 3, method 2. So method 2, can you handle? Then method 3 also replies, no. Then it removes method 2 from the call stack. Then again it asks the caller of method 2. So method 2, can you handle? So the caller of method 2, that is method 1. And method 1, can you handle? So it also replies, no. Then it is going to remove from the call stack. Then it asks its caller, so with the caller of method 1, main method. So main method, can you handle? So main method also replies, no. Then the control comes to the default exception handler. So if main method also fails to handle, then the JVM is going to call default exception handler. So default exception handler is going to terminate the program and print the call stack. That means where prints the class of the method, full class of the method, the message of the method, and where it actually happened. So it actually happened in method 3.
So it is going to print the details of the exception and terminates the program. The default exception will do this. So I hope this one is clear to all, and if the generated exception is of type exception 0, then this statement 2 is also not going to execute, statement 1 is also not going to execute, all these statements are not going to be executed. So I hope this is clear to everyone.